Hey there, and welcome. Today, we're going to tune into this invisible orchestra that's playing all around us, all the time. Yep, we're talking about waves. They're the fundamental way that energy gets around in our universe. So over the next few minutes, we're going to break down what they are, how they travel, and maybe most importantly, why they're the secret sauce behind pretty much all of our modern technology.
All right, let's just jump right in with a question. What on earth could possibly connect hearing your favorite song, feeling the warm sun on your face, and making a call on your phone? I mean, they seem totally different, right? But believe it or not, they all operate on the exact same physical principle.
Well, the answer is that right now, wherever you are, even if it feels perfectly still and quiet, you are literally in the middle of this invisible, energetic dance. There's this constant flow of energy that makes, well, everything work. And that dance is performed by waves.
So let's pull back the curtain on this whole invisible dance thing. What is a wave, really? Turns out the answer is both way simpler and, honestly, a lot more profound than you might think.
Okay, so here's the biggest misconception that pretty much everyone has at first. We think waves move stuff. You see a big wave at the beach and it looks like a wall of water is physically moving towards you. But that's not what's happening. Not really. Waves aren't about moving stuff, they're about moving something way more fundamental.
And that something is energy. That's it. That is the absolute key. A wave is basically a delivery service for energy. It's how energy gets from point A to point B.
So if we want to get official about it, the scientific definition is that a wave is a disturbance that carries energy from one spot to another, but, and this is the important part, without actually moving any material along with it. The material, the water or the air, it might wiggle around or vibrate, but it pretty much ends up right back where it started.
And this is the perfect way to picture it. Imagine you're at a sports game and you're part of a stadium wave. You stand up, you throw your arms up, and you sit back down. You don't run around the stadium, right? You stay in your seat. It's just the energy of the jump, that disturbance, that travels all the way around the arena. That right there is a perfect wave.
All right, so now that we know what a wave is, it's an energy delivery, let's look at how they're grouped. In physics, we basically split them into two big families. You can think of it as a tale of two very different kinds of travelers.
On one side, you've got mechanical waves. Think of these as the social butterflies of the wave world. They need a medium, some kind of stuff to travel through. So air, water, a guitar string, anything like that. Sound is the classic example. It needs air molecules to pass the vibration along. That's why in the vacuum of space, it's completely silent. No air, no sound. But on the other side, you've got the lone wolves, electromagnetic waves. These guys don't need a medium at all. They can just cruise right through the empty vacuum of space, no problem. This is where you find light, radio waves, and X-rays.
Okay, but there's another way we classify waves, and this one is all about how they actually move. It comes down to a really simple question. Is the wiggle perpendicular or parallel to the direction the energy is actually going?
And the two types are actually pretty intuitive once you see them. First up, you have transverse waves. The easiest way to picture this is a ripple on a pond. The water itself moves up and down, right? But the wave of energy moves forward, across the pond. The motion is perpendicular. And here's a cool connection. All those lone wolf electromagnetic waves we just mentioned, light, radio, all of them, they're all transverse waves. Then you have longitudinal waves. The best analogy here is a slinky. If you push one end, you see the coils bunch up and then spread out, in the exact same direction that the energy is traveling. That parallel motion, that is exactly how sound travels.
So we have these different families, these different kinds of wiggles, but let's get to the big question. Why does any of this actually matter? Well, this is where it all connects directly to our everyday lives in some really huge ways.
It matters because once we understood the basic properties of a wave, things like its frequency, which is just how fast it vibrates, and its wavelength, which is the distance between its peaks, we realized we could learn to control them. We could basically harness these invisible rhythms to do incredible things for us.
And oh boy, did we. Our understanding of waves is how we can broadcast music across an entire continent with radio waves. It's how we use the super high-frequency vibrations of sound in an ultrasound to literally see inside the human body. It's how we talk to satellites orbiting hundreds of miles above us to get a GPS signal on our phones. Honestly, almost every single piece of modern communication and medical tech is built on this foundation.
So, in the end, understanding waves really forces you to see the world in a new light. It's not just a static collection of things. As this quote says, our world isn't just made of stuff, it's made of motion. Waves are the rhythm of the universe.
They're the constant, invisible transfer of energy that makes everything happen. Pretty incredible to think about, isn't it?